Hi, my name is Mei Chen Ye from National Taiwan Normal University. I will present our work. It's a generative and adaptive approach for multi-label generalized zero-shot learning. So in a multi-label classification problem, the goal is to recognize all of the objects in one image. And in generalized zero-shot learning problem, we have defined some scene classes. The goal is to recognize objects. However, some instances may not have been observed during training. So in this example, elephants is from unseen class. But however, we may also have a test instance, rabbits, it's from seen class. Combining both, in this paper, we address the multi-label generalized zero-shot learning problem, where the goal is to recognize all of the objects in one image. Some of them may come from scene classes, like a monkey, like a lion. However, we may also have some instances that come from unseen classes. The goal is to recognize all of them. So in zero-shot learning, we usually assume the availability of a semantic space that relates seen and unseen classes. So in this semantic space, each class label has a semantic embedding. And if you look at the literature, recently the generated methods are quite popular to address the zero-shot learning problem. The idea is to synthesize training samples for unseen classes. So by using both of the real visual features extracted from seen classes and also the synthesized visual features computed from unseen classes, we can have a fully observed training set to train our model. This is quite successful for single label zero-shot learning problem. However, it's not trivial for multi-label setting because we don't know the location of each label in one image. So the question is how to synthesize multi-label visual features from multi-label images. In this paper, we present a new approach based on the generative paradigm for multi-label zero-shot learning. In particular, we convert one image into a label classifier. This adaptive nature facilitates the integration of a single label feature generating model to create multi-label features from multi-label images. So here comes the architecture of the proposed method. It consists of two modules. The green box represents a visual feature generator. So the input is a embedding, a semantic embedding, and a noise vector. The output is a visual feature. And it also has this IAC module. The IAC is Image Adaptive Label Classifier. The input is a visual feature. It may come from a real visual feature from scene class or a synthesized visual feature from the generator for unseen classes. The IAC converts the visual feature to a label classifier that is going to perform in the semantic space. So the capital C here represents all possible labels. So the classification is performed in the semantic space where we can get the probability of each label belonging to this input image or not. Therefore, we can use a conventional cross-entropy loss to optimize the model. The whole framework is end-to-end trainable. So to give you more details about this image adaptive label classifier, we can compute the visual features using a backbone model, like a convolution neural network, from one image. Then IAC converts this visual feature to a classifier. The classifier is used to differentiate between positive and negative labels of this image. So in this example, dog and car and cats are the positive labels, while the others are negative. So different images may have different classifier weights. Also, that gives us some flexibility to perform the classification. So it's flexible in that images of the same class can have different semantic classifiers. It also facilitates the task of feature generation because now we can simply decompose a multi-label training sample into multiple image label pairs. Then we can process the pair one by one. And the matching is more flexible between one image and its label because a label is considered correct if its embedding is on the right side of the decision surface. So the general presented in CVPR 2019. So we evaluated this approach on two benchmark data sets, the Pascal VOC and NUS wide. And the results showed that the approach has a competitive performance to the state-of-the-art methods. In summary, in this paper, we propose a new approach for multi-label generalized zero-shot learning problem. With the generative and adaptive characteristics, we demonstrate that this approach is beneficial to address this challenging problem. That's the end of my presentation. Thank you for your listening.